73. We're going to talk about applications of trig. How can we actually use trig in the world? That's a great question. I hope I answered.
It's a trick question.
How about
you
Incorrect question.
as it has to.
You failed.
It's fair. So today I hope to answer some questions. The first thing that you have to know about trig, you already know. What's the most important thing?
So,
And you know what all those letters mean, yes?
Yes, ma'am.
Cosine adjacent over hypotenuse. Tangent opposite over adjacent.
And all of those, it's not the sine opposite over hypotenuse, it's sine of an angle,
Opposite over.
okay? Don't forget about the angle, we'll have to use that today. Because today we're specifically going to talk about the angle of elevation and an angle of depression, okay? An angle of elevation is from a point looking up, okay? If you have an angle of elevation, everybody, if you're standing or sitting or wherever, can see something by looking up, yes or no?
No.
You can see the ceiling, you can see the top of the edge. If you're outside, you can look up, you can see the top of the building. You can
Unless you're
see.
blind.
You can't see anything.
Yeah.
So, if we are looking up, we can see things. That is called an angle of elevation. Everything with the angle of elevation, we're going to talk about the horizontal or the horizon.
Like where the sun sets.
There's a horizon. It's a horizontal line, and this, when you're looking up, will be the angle of elevation. If you are standing on top of a building, if you're in a plane, if you're somewhere high on top of this building, and you're looking down at something, that is an angle of depression. We are still going to look from the horizontal, from wherever you are standing, there's a horizontal line of the horizon. You're going to be looking that way, and the angle of depression will be from that horizontal, and it will be going down.
So depression is down?
Yes.
That makes sense.
Is this when we're going to do the calculations of the building height?
Yes.
Are we going to do that with our building?
Yes.
When?
Probably tomorrow or Wednesday. We'll see.
Yes.
Are we
So
going
we'll
to
go
do
outside.
other buildings in this city?
No, city.
That'd be
No.
great. We should do that just like
tall
Nashville.
building in the square.
No.
The clock tower.
We should go on a field trip to outside.
Business.
We will go on a
Right
trip
now.
to outside
Square.
later this week, either tomorrow or Wednesday, depending, because you have to make something. You have to make something to be able to use. Okay?
I think we should go
Alright,
to Nashville.
so what you need to recognize is an angle of elevation that's from this point looking up. Okay, angle of elevation, you're looking up. Angle of depression, you got your horizontal and you're looking down. You're at the floor, you're on a plane, somewhere, you're looking down. Can I ask you a question? The horizon from your angle of elevation here, or if you're up here looking down, the horizontal lines or the horizon, what do you know about those dotted lines?
Parallel.
They have to be parallel, yes? It can't be any other way. Okay, yes.
Do they always have to be flat?
Yes. Yes, because we can make an assumption that you're in an airplane and they see a pond down below. We are still making the assumption, well, depending on how high they are, you're going to be able to see it for a while.
Oh,
If they're
The
really
pilot
high.
sees the pond.
Okay?
I'm making
But
Pirate. Oh, he said pirate. That was so good.
we make an assumption that they're flying level We don't care where they're going after they're at this spot. We're making an assumption the plane is not angled down. We're making an assumption that it's a level plane. We also make assumption that buildings come down at a right angle.
What if
Okay.
they don't? Like the leaves, like,
We are not going to Italy to measure the height of that building.
We'll do that when we visit.
So, when you go to Europe, do that.
We should
Okay.
go to Europe with us in Devon so we can find.
That sounds like an amazing idea.
Have you been to Europe?
Have I been to Europe personally? Yes.
Did you go with a school trip?
No, I've not been on a school
you
trip.
want to go.
Do I need to go on a school trip?
I have a question.
Yes.
Is the angle of depression and the angle of elevation the same if it's on the same line? Because they are opposite angles.
They're alternate interior angles.
No, just kidding.
Ah.
So we will relate those too. It's very important that we know they're parallel. Yes. Alright, someone is standing on a balcony, 40 feet above the floor.
Don't jump.
That's
Okay? They're standing on a balcony, 40 feet
the fourth floor.
above street level. Let's just say that. They see a car. As they look down, the angle of depression is 38 degrees. How far is the car from the building?
Oh.
Okay?
Okay, will you give me the
Here we go.
will you write the numbers?
You
on
need
it?
to write down the angle of depression.
Is that
Wait just a minute. Equals 38 degrees. How far is the car from the building? You know they're 40 feet high. I would like to see your drawing. I would like to see where you're going to put the angle of depression. Because they're standing on a balcony and they're looking down. So where would the angle of depression be, Gray?
Good question. I'm not sure.
Go back.
Yeah, I'm
38 degrees. If we're standing above, high, and we're looking down, where is the angle of depression? Right there, right? So what lines do we need? If I want to go back here, do I need the horizontal line?
No. Yes.
No.
Do we need a triangle?
Yes.
Where's the angle of depression?
Top.
Up top, here?
Yes.
Or
No,
here?
Right there, right
Or
there.
here?
The second here. No, the second here.
Alright,
This is
this
not
is the most common mistake. Where's the angle of depression? Is it inside that triangle?
No, it's outside.
No, it is outside. It's from the horizontal line down.
But
So this is 38 degrees. That is
was
the
my whole
angle
problem.
of depression. Yes.
so could you like set that, like subtract that from 90 to find the angle inside?
We could, yes.
Indeed. Indeed.
But can I wait? Wait. Horizontal line and the ground below. They should be what? Parallel. So do you know this angle right here?
Is congruent to that said angle.
How do you know that?
Because of the
Alternate interior angle. So you know the inside piece at the bottom is 38 degrees. All buildings come down at a right angle. What are we looking for? Brogan. What are we looking for?
That's a good question.
We are looking at 95.
How far is the car?
Okay, so are we looking for this length?
Yeah.
Are we looking for this length? Okay, stop. Okay, I'm asking Brogan.
Yes.
Which one are we looking for?
Yes. That's X.
You were looking for X. How far is the car from the building?
Oh no.
Do you agree? Do you agree, Jacob? We're looking for Y and not X.
Mm-hmm.
Because it's on the ground.
Because it's on the ground. And if I ask how far is the car away from the balcony,
Then you find that.
then we would want to find the hypotenuse. I don't want to find the hypotenuse. I want to know how far is the car away from the building. So we are looking for Y. Okay? Which trig function? So Katoa. Okay, I would really like not that. I would like to call on, hey Anderson, which trig function? But I don't want to say your name first. Because then everybody else stops thinking. Which trig function, bless you, do we need to use to find the value of Y? Toa, what are you going to write? What's your equation going to be?
Tangent equals
Tan what?
38.
Tan 38. Tan of an angle equals what?
So it'd be 40 over y.
Wait, can you do it another way?
There's 12 different ways to do that.
Okay, cool.
Okay.
What?
Maybe I'll get
Wait,
the
can you show us on
There's 12.
So, from this equation, can you solve for Y? How are you going to solve for Y, Gray?
Will you? I don't know which one.
Yes, I got this.
Well, do you want to get Y by itself? You also want to get Y out of the denominator. What are you doing to get Y out of the denominator? By multiply both sides by 40. I'm going to have 1,600 over Y. So you want to multiply by Y. Yes, these Y's cancel. So you have Y times tangent 30 equals 40. How do you get? What do you do to get Y by itself? Divide by tan 38. So Y equals 40 divided by tan 38.
51.197.
Is that what everybody got?
51.19766
I'm in radians.
Why?
I don't know. I didn't change it.
Your calculator made it obviously go there. So 51.
Wait, so this
Feet? Feet matter?
Yes.
Yes, feet matters. Alright, using tangents.
That's crazy.
That
You
sounded
can
a
tell
lot
how
harder
far
than
it
what it
is just
actually
because of the.
Yes.
There's a
Yes, it gives you sine, cosine, tangent. Alright. Somebody's flying a kite. Okay?
Like Lydia's good last night.
We all flew kites in first grade, right? So there's a person. And the string we're gonna say is 50 feet long. And then you got the kite up here.
Wait.
I don't think what?
Oh,
The angle of elevation from the person flying the kite is gonna be 40. There you go. The angle of elevation is 42.5 degrees.
That would be alright.
Oh
Yeah.
wow. Had to do with like
And that goes inside of the triangle by the person's hand.
Just a minute. How far above is elevation go? Between the person, like, am I gonna draw the horizontal line down here?
No.
Should I draw it right here?
Yes.
Should I draw it above somewhere?
Yeah.
From right here, from where the kite is, from where the string is in her hand.
From their eyes.
So is it here going up?
Yes.
Here we go.
Wait, don't we have to know how tall the person is? too?
I don't know.
No, because we drew the horizon line from where they are looking, so no.
But it says how far is it from the ground?
Exactly.
Amount of height.
Now we
So,
know that
this is-
limit.
This is the question that you will need to answer for tomorrow or Wednesday whenever we get outside.
I'll call her.
When you look up and you look through something and you find your angle of elevation, how far off the ground are you?
Not very.
Okay. You have to account.
Oh, where you could just like get the string and put it on the ground. Make it a lot easier.
I mean, all you have to do is add your height.
Okay. And the issue is this her total height?
It's her eye height.
She's reaching up in the
It's kind of like.
It actually is only about to her neck. So I'm just gonna say she is
got it right.
4.5 feet.
tall.
She's only 4.5 feet.
What's
From
her?
her arm, it's a kid.
She's like
You
5
put
feet.
holding it
She's holding it right out this way. She's not holding it above her head. Because, I don't know, she's keeping it steady. Alright, shh. Anderson.
Is the angle of elevation and the angle of depression almost the same?
No, absolutely not. Where it's measured from. Okay? Should you always keep your angle of depression down there at the bottom? Okay? But, they're not the same thing. Alright, what's the equation you use, Brogan?
I wasn't too sure. Because you kind of helped us on the last one.
Okay, did you draw a triangle?
Yeah, so the triangle. We're trying to find how like that.
So should I draw this down?
Yes. So that's what you're trying to find, and then you gotta add that.
Trying to find, so,
I don't know.
alright, so what equation should I use? John, help me out with an equation.
Use sine
Why are you using sine?
because you have the opposite of the variable and you have a hypotenuse.
So opposite over hypotenuse. So tell me the equation we're using.
Sine 42.5 equals x over 50.
Oh wait, that's my point.
Alright, so how are you gonna solve this? Multiply both sides by 50. So what is 50? Sine 42.5, right? The numbers in the bottom, you simply multiply.
That's
Numbers
what
in the top,
I would
you have to
rather
divide.
I would rather it be
Yeah, I like it.
What?
doing
It's more simple.
syntax here.
Oh, okay.
Honestly, great is a lot harder.
Yeah.
Yeah, it's really hard.
Stack the calculator over here. This is charging. My calculator went red this weekend. Like it was.
33.77.
38.2.
That's because you added 8.
Alright, then did you add the 4.5? So x equals what, Gray? 7795. Then do you add 4.5 feet?
38.3.
38.3 feet above the ground.
That's pretty good.
Pretty good. Okay. With human error, we're always going to have some
That's like
approximate.
as tall as the girl on the ledge of the building.
Mhm.
38 feet off the ground.
point. Alright, somebody else. Standing on a building. This time they're looking at an angle of depression that is. We can do building to building.
We
I
can
won't-
top of one building to the bottom of another.
That
Or
just
the top of one building to the top of another. That'd just be a
Yeah.
straight line.
So
Unless
that's
they're different lines. Well,
You mean like that?
I was thinking the same.
Ooh, I do not want to do that.
Alright, how about let's assume you're standing on your balcony, you're in the penthouse, so this time you're at the top.
let's go.
Okay. This time you're at the top, and that's gonna be, let's make it 80 feet.
Stop, baby.
Rooftop balcony, and you look down with an angle of elevation of 65 degrees.
65.23 inches.
Inches.
What? Inches?
Were you about to write my name, Miss Evans?
No, I was just fixing to write elevation,
Depression.
but I didn't mean to. Depression was 65.
That's the
Point
depressing.
23.
I wasn't gonna do that.
That
No.
looks like depressing.
Yeah, sorry. Depression was 65 degrees. That was when she saw. Was she gonna see a turtle?
No.
A
A
cactus.
wallaby.
A wallaby.
No, a succulent.
Exactly.
Wallaby.
A succulent.
Also, she saw from standing on her balcony
A cactus.
a cactus.
Shout out to
Okay. So she saw two different things. My question to you now is how far apart is the wallaby from the cactus?
Where is the
No,
wallaby?
it should be a wallaby and a giraffe.
Where is the wallaby?
They're at an angle of depression. Angle of depression.
Two different angles.
Two different angles.
Very-
As you were standing on the top,
So it's
she's on the very top,
So she's 80 feet up.
80 feet above the ground. Angle of depression, she sees a wallaby. But then she looks farther this way and she sees.
a giraffe.
But how tall is she? Because that's how high
No.
she is above 80 feet.
No, she's still standing on the balcony, whatever, she's level with
Wait,
it.
how is the wallaby? Is the wallaby taller than the cactus?
What?
That's what
No, the wallaby's
These are both things are on the ground.
Oh, never mind.
Wait, which one's taller?
Big cactus.
Oh, the cactus is way taller than
No.
oh, no,
It's
no,
it looks like a spot on the ground. You can't tell height from up there.
It's like so.
Okay, stop and start drawing.
The wallaby should be farther.
That is a huge question. Which one should be farther away?
So we're looking for this bit right here.
How far? So can you tell? One's gonna be like this,
Do you subtract?
and then one's gonna be like this, and you're looking for this.
Oh,
How far? Can somebody logically tell me? Raise your hand. Which one is farther away? Go ahead, Dalton. The W is farther away.
No.
Wait.
What? Why?
I realize I have messed up and I'd like to change my answer.
I know.
Because, you see, I was going based on the angle from the building to the diagonal. But I learned from my mistakes and realized that it's of the horizon. So therefore, the one that would be further away is C.
Okay, so this angle right here
Because
is
she's
a
looking
smaller
down
angle,
at- yeah.
so that would
Oh,
probably be the
smart,
40
smart.
degrees. Be the cactus. This whole angle, here to here, is 65 degrees.
So it's not. Oh, I did it.
wait, you didn't label W on the bottom.
Oh, I'm so sorry.
It's all good. I forgive you.
It's a good thing you were smart.
So the angle for the first one is 50 degrees. 65. Oh yeah, 40.
Questions? Where's the triangle?
I'm at the end.
We got two different.
There's two different
Oh,
triangles.
there's two triangles.
Anderson, help me with one triangle.
You got from the bottom of the building
Bottom of the building
Bottom layer.
to the W.
and then up to the top of the
I wish I had different colors.
Yeah. Do you know what either one of these inside angles of this triangle are?
Yeah, the first
What?
A
Wait.
number.
Anderson was helping me. Can you help me with angles inside this triangle?
Well, you can do 90. No, you can't.
Wait, stop making more harder. Stop making it harder. You know a number. Take the number you're given. Is that number inside the triangle?
Yes.
Where is it? At the W. What is it?
So they are the same, the sevens.
Alternate interior angles will always be the same.
If there are
Okay.
alternate interior angles, then they be the same.
But they will always. But it's where you're measuring it from.
But you were talking
But
about
it's the angle of depression. Okay.
Depression.
Angle of depression, you're measuring from the top, looking down. Okay? Angle of elevation, you're here, you're at the bottom, measuring up. Okay? It's a verbiage thing. Okay? If you have a number, okay, they will always be the same. Why? Because of alternate interior angles. What are you looking for?
That's the building to W.
From the building to W, I'm going to put a Y here. What do you have? What trig function are you going to use? Jacob, what trig function are you going to use?
Sine, you have the opposite.
So we have opposite.
Cosine, because the adjacent.
Okay, so we're looking for an adjacent.
You don't have the hypotenuse.
You don't have that hypotenuse, so you can't use.
Tangent.
So you have to use tangent. So what are we writing? What's our trig function? Trig equation.
Opposite over hypotenuse.
So what is that?
Or
Tan.
adjacent. I mean, second.
So in an equation, tan what?
80. Or what?
Tangent
Tan
of an angle.
Oh no, I messed it all up.
Tan 65 equals what?
80 over y.
80 over y. Okay, I'm going to give you a huge hint. I know I heard you say, I don't like it when the variable's on the bottom. All you do is switch them.
Yeah.
All you do mathematically. Okay? You don't have to take the long way around. So y equals 80 divided by tan 65.
Which is
Which is what?
37.3.
Well, hold on. 37.30.
Okay, keep that number.
37.
Okay? What else do you have to know?
So C.
Is there another triangle here?
Yes.
Yes, John, help me out. Where's my other triangle at?
No, I'm still on the last bit.
We already gave the number for that.
Yeah, I know.
Just because you have the answer doesn't mean you know.
Thank you for saying that, Anderson.
Thank you, Anderson.
Good job.
So that angle would be duh, which was adjacent to the opposite. So it was y over 80.
Oh,
And
you
then
mean
flip-
opposite over adjacent?
Oh wait, opposite over adjacent. My bad. So it was 80 over y. And then you flip those two. Okay.
You just replaced the y and the tan 65. They just changed
So
places.
it's not 65 divided by 8.
No.
Okay. And now we're looking for C.
Now we're looking for angle C. Do you know angle C?
C. I do not know angle C.
Yes, you do, John.
But you do,
John. Yes, you do.
Let's draw the triangle.
25
Yes, I just shushed you. Be quiet.
Oh wait, sorry, Kate. You do know what it is.
Do you know what angle C is?
Yes, yes, you do, John.
Yes, I do. 20 degrees.
Spit it out.
Okay. You should not.
40 degrees.
You mean- You should not be plugging anything in your calculator. Alternate exterior, alternate interior angles will
Would it be 40
always
degrees?
going to be congruent.
Right there inside your
Sure, because you're going to learn this lesson on your own anyway. your equation, John?
Opposite over adjacent to one. Okay, yeah, so 80 over 37, whatever it was, I think. Was that the answer that we got for that one?
What's your equation for the red triangle? Forget everything that's in pink or purple. What is your equation just for the red triangle?
10, 40 degrees equals 80 over x.
Okay. I'm gonna put a Z here. Because it's the whole thing, right?
Wait a second.
Wait, you want Z?
Oh yeah, that simplifies it.
I mean,
You have to find
you
Z.
can't solve. You don't have the ability to solve just for X from here to here.
You can form a new triangle. That's not a triangle.
I mean, yeah, that's a triangle.
But it's not a right triangle, so you couldn't use this.
We will.
She was talking.
To use trig functions without right triangles. Right now, you can't use trig functions
Would it be the
until
inverse?
without right
of the-
triangles.
Is it the inverse stuff?
So here we go. So Z equals what?
95.
Where is it? 95.3.
Keep falling.
All right. So what is Z?
95.34028741
Alright.
approximately.
So take that decimal number, subtract it from your other decimal number. Do not subtract minus 37.
37.3.
Whatever decimals you have. Keep all the decimals. That's amazing.
I did.
How far is the wallaby from the cactus?
Approximately 58.03567476.
About 58.
About
Yay, Joe Wallaby!
58.03567476 degrees.
That's enough of that.
It's distance.
Feet, approximately.
All right. So you can figure that out.
What if they were like, not straight lines?
We are making an assumption that on the street level,
Always assume.
it's always going to be level and at a 90-degree angle.
What we learned about that,
What?
that's the other point.
Yeah, I mean, you can do it with, goes with not right angles. Yeah. Or the wonderful day when I did this, what we're going to do, when we went out and we measured, and I did not take into account, eventually the farther back they got, the more it sloped up.
Oh no.
And so the people that were in the back were not as
Didn't do the same
accurate. They didn't do the same thing. So we will try to be as level as possible. All right. Example 4, they do some applications, a survey. That's from one building to another building.
Survey says.
You said survey says.
Wait, like survey?
Like the people who set up the tripods and the level things, they're surveyors.
Also, you do that in public school.
In public?
Like in the parking.
They survey things all over the place. Alright, can you walk through example 4?
I mean, I'm sure.
Okay, stop. Stop. Right there. Okay? You guys, some specifically, are starting to see how far are we going to push the 7s before the school year ends. Stop. Okay. Now, look at example 4. I'm going to see if I have what I used last year.
Are we doing example?
Yes, we are. As a
You're
class.
reading example 4.
You want me to leave the class? I think Aaron should leave.
Leave it, baby.
Have we done the rice thing?
No.
Oh, with the paper, where you fold the paper.
Were you guys in here during reading week last
Yeah.
year?
Yes.
I wasn't.
Rice in the shapes.
Wait, yes, I
And
was.
like it
I
doesn't
watched
take
it.
up the same.
And you do volume.
I mean, I was sick.
I remember
Oh,
that.
and then someone kept saying all that.
Addison, I remember Addison.
We kept letting somebody say that.
I thought it was Emma. Man,
On the side. I was doing it on that side. It's what you missed. What's this side to be?
We can do that tomorrow. Wednesday.
Okay. Alright. Tomorrow, we will partner together.
Oh.
We will have a partner and we will make.
Wait,
As long as I go.
choose our partner.
I'm probably gonna say no to that.
That's probably a good decision. Wait, why did you ever say no to anything?
I don't play this.